Hello there, welcome to the October 2020 paper. Here we're looking at question 5. Figure 1 shows the design for a structure used to support a roof. The structure consists of 4 steel beams, AB, BD, BC, and AD. Given that A to B is 12 meters, B to C is 7 meters, and the angle BAC is 27 degrees, that's already on the diagram. Find to one decimal place the size of the angle ACB, so that's this angle here. Now first of all, I'm looking at this angle and I'm thinking, that's quite a big angle. So if I get a small answer, I'll know I've gone wrong. So let's get started. Now what we've got to do is sine or cosine rule, I assume, for this question here. I think the sine rule would be pretty helpful. So I've got the pair of opposite sides and angles 7 and 27 match up, and 12 and this new angle also match up. So if this value x is what we want to work out, then I want it on the top of the equation. So my version of the sine rule is going to be the one with sine on the top. So sine x over 12 equals sine of 27 over 7. So therefore, if you go through and work that all out, work out the right hand side, times it by 12, and then inverse the sine. Let's just now quickly do that on the calculator. Sine 27, close brackets, divide by 7 equals, then multiply by 12, then inverse the sine on it, and you get 51.1. So 51.1 is the answer for x, but it doesn't really feel right because x looks to be a massive angle here. So it's probably one of those questions where you have to do, actually, x equals 180 minus 51.1 equals, let's do that on the calculator, 180 minus answer, that'd be 128.9. So to one decimal place, 128.9. The reason for that is, if you imagine the sine graph looks like this expression here. What we did to start with was we worked out what sine of 27 over 7 is, times by the 12 on the other side, and that gave us, let's just go back a little bit on the calculator, 0.778. 0.778. Now there's actually two angles that will give you 0.778 as your answer, one of those being 51.1 and the other one being 128.9. So the way I worked out the 128.91 was I used 180 coming backwards by that 51.1 angle to get my 128.9. So there we are, that's the answer for part A. Now moving on to part B. The steel beams can only be bought in whole meter lengths. Find the minimum length of steel needed to be bought to make the structure complete. So what I'll need to work out then is some more lengths on these triangles. I think the first thing we'll have to do then is, we've got 7 here, we've got 12 here. We may have to work out the side of this length here. Or I suppose we could work out some angles instead. Oh, hold on, we've got both sides of this triangle equals 7. So we've got BD is also equal to 7. So if we also now know that this angle up here is 128.9, then this angle round here will be 180 minus that. We know that already, that's 51.1. Now we've also got an isosceles triangle here, so this angle up here will also be 51.1. And this angle here is going to be 180 minus those two angles. So if we type in 180 minus 2 lots of 51.1, then that's going to give us 77.8. So that angle there would be 77.8. This angle here is going to be 180 minus those two angles. In fact, we could probably work out the whole angle immediately, couldn't we? So look at the bigger triangle here, 51.1. Bear with me on the calculator here. So 51.1, and then add 27. And then do 180 minus answer, we're going to get 101.9. So this whole angle down here is 101.9. So now what we're looking to do is in one swoop work out what the length from A to D is, because we've got 12, 7 and 7, we just need to work out what AD is equal to. So what we'll do now is we'll use this 101.9, this 12 and this 7 here, and do a cosine rule on it. So it's going to be A squared equals 12 squared plus 7 squared minus 2 times 7 times 12 times cos of that 101.9. So therefore, if we work out all of the right hand side all together, I've currently got 101.9 in my calculator, so it's 12 squared plus 7 squared minus 2 times 7 times 12 times cos of answer button equals 227.6, and therefore square root it 15.08. So that's quite annoying really, because we'll have to buy our steel bars in whole meter lengths. So therefore the minimum amount of steel needed to buy is going to be 16 for this 15.08. So 16 plus 12 plus 7 plus 7, and that will give us an answer of plus 12 plus 14, 42. So there we are, 42 meters of steel we needed to be bought to build this construction here. And there we are, that's the answer for question 5 there. It was a sine and a cosine rule question, given a little context. There we are, let's move on to question 6.